Welcome to part 9 of module 2, which is forecasting of production and service system planning part 1. So till now, in the first 8 part, we were discussing multiple time series forecasting methods, such as we have discussed knife forecasting, moving average, weighted moving average, as well as simple exponential smoothing. So all those methods were good for if we have only the level component in our time series pattern. But we have seen that if we have level plus trend component, and more specifically we have seen that if we have a linear trend component, we have seen the two methods. One is the adjusted exponential smoothing method, as well as we have discussed the linear trend method, or you can call it as also as the simple linear regression for the time series data. Now we are going to talk about if we have there is a level component, but if there is a seasonal component over there, then how we are going to predict the future. As well as we will also discuss that if we have the trend plus seasonality component is over there, so how we are going to predict that one. So let me first of all discuss what is the seasonal, or yeah, the seasonality pattern means. So the seasonality pattern could be on a monthly basis or a quarterly basis. So how you can define this seasonality, that is, we can say that the data having the amount of the seasonality which it is deviating from the average value of your data. Okay, so either the seasonality could be the upper side, or either it could be the downside, which is basically the deviation from the actual or the average value, right? Now, basically, what we are going to do is, in order to calculate the seasonality part, so we are going to calculate the seasonal index. So basically, that is going to adjust the forecast regarding in order to incorporate the seasonality component. Okay, so how we can calculate that seasonality index? The formula to calculate the seasonal index is basically the average demand for the season. So the season once again could be a monthly or quarterly or a weekly, whatever the season is. So let's say if we are saying that the January 2020 we have a demand, and January 2021 we have the demand. So the average season demand means the value of the January 2020 and the value of the average value of the January 2021. So that is the average demand for the season, which is on a monthly basis for the 2 years. Okay, and then we are going to divide with the deseasonalizing it. Okay, which means we are going to remove the seasonality in the data. Okay, so in order to calculate the seasonal index, we are going to divide with the deseasonalized average demand. Basically, that is the average of the entire year. Okay, so once again, the seasonal index is basically the percentage value which is indicating how much it is above or below the mean value. Okay, how much it is above and below, which is basically indicating by the seasonal index. So how we are going to calculate? So let's see if we have this example. So I will also show in the Excel as well. So this is the data set we have. Okay, so we have the 2 year data, that is 2018 and 2019. We have the monthly data, and we are right now assuming that we have the monthly seasonality in the data. Okay, so if there is a monthly seasonality, so how we are going to calculate the seasonal index? Okay, so first of all, we are going to calculate the average of the seasonal demand, because it is a monthly seasonality in the data. So what we are going to see is the January 2018 and January 2019's average. So this is basically 36 plus 98 divided by 2. That is the average seasonality of the demand. Same is the case for the February, March, and so on. Okay, and then once we have calculated these average seasonal demands, then we are going to calculate the deseasonalizing. So how to calculate the deseasonalize is nothing but simply the sum of these seasonal average demand. Okay, So this is basically 93. Okay. Now, in order to calculate this seasonal index, what we are going to do is we are going to divide this seasonal average demand, which is 67, divided by this one, which is basically we have repeated this one. So 67 divided by 93, 72 divided by 93, and we are getting this one. So that means the seasonal index less than 1, it is indicating that in that particular month, the demand was below the average. So the seasonal index is greater than 1, that is indicating the demand was above the average demand. Okay. Now, in order to forecast, or you can say on a monthly basis for the next year for every particular month, what we need to do is we need to calculate the forecast value for the for the year of 2020. Okay, in order to calculate the every month demand of 2020. So the one way is that you can apply any particular forecasting method or to predict the year 2020, and then you can deseasonalize. Okay, so any either apply simple moving average, exponential method, or a linear trend, whatever you would like. So what I am going to do is, in order to predict the year 2020 demand, so I am going to apply a simple linear trend line. Okay, so for that, the year 2018 is representing with 1, the year 2019 is represented with 2. Okay, and the actual demand is basically this is the 2018, the sum of this one, that is the 2018 demand, the sum of 2019, that is the total demand for the year 2019. Okay, now, using this data set, we are going to find out, because we would like to apply the linear trend line, which we have discussed in the last lecture. Okay, so we need to find out the intercept and we need to find out the slope. So we can apply the Excel formula of intercept, okay, as well as the slope, which I will also apply in a minute in an Excel file. Okay, and then using these two values, we can predict for the year 2020, that is representing the year third. Okay, so after 2003, and then this is going to be the value of a, which is 869, plus we have the slope, which is 168 multiplied by 3. So we will get the value of the forecasted value of year 2020. Okay, then in order to get the monthly average forecast, what we are going to do is we are going to divide this value in the number of seasons in that uh, uh, in that time period. So because we have the monthly demand and we have a yearly data, so we are going to divide it with 12, so we will get the average monthly forecast. Okay, so now, in order to calculate the every month seasonal forecast, what we are going to do is we are going to multiply this 114 multiply by 0.72. We will get the forecast value for the month of January. Same is the case 0.77 multiply by 114. We are going to get the forecast value for the month of February, and so on. Okay. So remember, one thing is the sum of this seasonal index must be equal to the number of periods. Okay, so that is basically the 12. Okay, the sum of seasonal index must be equal to the number of season, which is the 12, because it's a monthly seasonality data, and the sum of forecasted value. Okay, so that is basically the must be equal to the annual forecast. So the sum of forecasted value, which is this one, must be equal to the annual forecast, which is 1373. Okay, let me apply in Excel as well. If I'm going to say is, so what we have done, we have calculated the average of these two over here. Okay, and then in order to calculate the seasonal index, we need to deseasonalize the monthly demand. So how we can do that? So we are going to simply sum of these values. Okay, so we have taken this average value. Okay, not the sum, the average value of this one. Okay, so once we have done this average, so this is going to represent the every month deseasonalized, which means we have nullifying those seasonality. Okay, and then we are going to calculate the seasonal index. Okay, So that is basically 67 divided by 93, 72 divided by 93, 77 divided by 93. Okay, once again, in order to find out this forecasted value, what we are going to do is we have this years that is representing year 2018 and 19. This is basically the sum of values of their demand forecast. Okay, and then we are basically calculating the intercept. So intercept of this demand, and this is the time. Same is the case slope. This is the demand, this is a slope, okay, time period. And then for the year 3 we are going to forecast, which is basically a plus b into 3. Okay, that is basically this 3 time period. So we are getting this forecast value for the year 2020. So in order to calculate the forecasted value for the average monthly demand, so we are going to divide with the number of seasons. Okay, so that is basically the 12. Okay, now in order to calculate the monthly forecasted demand using the seasonal adjusted forecast method, we are going to multiply this seasonal index multiply by this 114. Okay, so we are going to get the monthly forecasted demand for the next year. Okay, I hope you got the idea. Now, let me apply the same approach. Okay, over here, when we have the linear trend as well as the seasonality. If you can see that over here in this time period, we only have the seasonality, so there is no trend component. Okay, so that means we have the level component over here, plus we have the seasonality component over here. But over here, we do have the linear trend as well as the seasonality. Okay, so that means in this case, the level component is there, that is the average part of the demand. Okay, and then we have the trend component, then we have the seasonality component. So how we can do this one? So this is the same way. So let me show you in the Excel. Okay, so now if I am going over here is, so we have this year. Once again I'm using the same case study data. So monthly, and the month is going to represent with number. This is the actual demand. So the first of all, we are going to calculate the average monthly demand. Okay, so the average monthly demand is going to be calculated for the January, because it is, once again I'm considering it's a monthly seasonality. Okay, so that is going to be the average of January 2018 and January 2019. Okay, so that is the average value of this one. Same is the case for the February. This is going to be the average value of the February 2018 and the February 2019. Okay, so once we have calculated this one, remember that these values are going to be same over here as well. So you can simply copy it, okay, and paste it, because these values are going to be same. Okay, so once we have done this one, and then what we are going to do is we are going to basically calculating this seasonal index. So in order to calculate the seasonal index, that is going to be this average demand divided by the sum of the actual demand. So the sum of this actual demand is basically 93. So we are doing it, that is with the help of this 93, we are calculating this seasonal index. Okay, now in order to calculate deseasonalizing it, so in order to calculate the deseasonalized, what we are going to do is we are going to divide this average monthly demand divided by, sorry, the actual demand divided by this seasonal index, right? So we are going to get this deseasonalized demand. Okay, so basically we are nullifying that seasonality part in the demand, or removing that seasonality part in the data. Okay, so now after deseasonalizing the demand, we are going to find out that trend component, that means the linear trend line forecast. So how we can do that? So we are going to need to calculate first of all intercept as well as a slope. So remember that we are going to calculate this intercept with the help of this deseasonalized, not the actual demand. Deseasonalized demand and the months. Okay, so we have calculate intercept, deseasonalized demand, and monthly demand as well as the slope. Okay. Okay, now once we have calculated this A and B, which is intercept and slope, we can calculate this linear trend line forecast value with the help of A plus B multiplied by first month, and then we can drag and drop. Okay, right? So you can keep moving and it will give us that forecast value, right? So once we have done this one, now in order to calculate the seasonality component, also incorporating that forecast in order to get the final forecast, what we are going to do is that is the linear trend forecast multiplied by the seasonal index. Okay, so once we have done this one, okay, so we can once again drag and drop in order to get the this fitted of the linear trend as well as the seasonality. The rest of the thing we know how to calculate the error, so that is going to be the forecasted value, okay, as well as the actual demand. So actual demand minus the forecasted value, actual demand minus the forecasted value, and we know how to calculate absolute error, error square, absolute percentage error, as well as the mean. So we have discussed this number of times in our previous lectures. So thank you so much. I hope you got the idea. If we only have the seasonality component, how you are going to deal it. If you have the trend and seasonality, how you are going to deal this one. Thank you so much. See you in the next video.